Good morning, everybody. Hopefully, we don't have too many of those Monday sleepies in our brain. Let's get ready to focus and take a look at the Test 18 review. So, here's one we haven't seen for a while. Two-step story problem and all about telling time. So, school starts at 8:15 a.m. and it's going to take Nick 15 minutes to walk to school. At what time should he leave for school if he wants to get there 10 minutes early? So it's going to start at 8:15. You got to think like a clock. He wants to get there 10 minutes early. So he wants to get to school by 8:05, right? Now you have to factor in the walk time. 15 minutes to walk to school. So go back 15 more minutes. 5, 10, 15. So it's no longer 8:15. What time is it right now? Take a look. It's not 8 o'clock for the hour anymore. The hour would be 7 o'clock. And it looks like it's 10 minutes to 8, but what time do we actually call that? That would be 7:50 a.m. Make sure to label the a.m. or the p.m. Not too tough if we approach it that way. You have to think like a clock. Let's see what else we have going on today. A half gallon of milk is how many quarts of milk? Well, if you're unsure, I highly recommend going back to that chart on lesson 85 and start off by thinking how many quarts are in 1 gallon. And you would find if you look that up there would be 4 gallons or 4 quarts in 1 gallon. So half of 4, hey, that's going to be 2 quarts, right? So here we have an improper fraction of 7/3, right as a mixed number. We're getting pretty good at this on that quiz we do every afternoon, but in case you're still unsure, anytime the numerator is larger than the denominator, that's a divide problem, right? 3 divides into 7 2 whole times, multiplies back 4 6, and it's going to subtract 4 1, correct? Our remainder is our numerator. Our divisor is our denominator. So 7/3 is really 2 1/3. Here we have a basic reducing problem. And remember, you want to divide it by the greatest common factor, the largest number. I mean, yeah, they're both even, and I could divide them both by 2, but you're going to end up having to divide more than once. Yeah, I could divide them both by 4, but again, you would end up having to divide more than once. The greatest common factor is actually 8. And it's okay if you don't pick the greatest common factor, as long as when you're all done dividing, you take a look and say, is that as low as it can go? So 16 divided by 8, hey, that's going to give us 2. 24 divided by 8, that's going to give us 3. If I look at both 2 and 3, there is nothing else I can divide into both of those numbers other than 1. And that would be silly because that's not going to change the answer at all. Let's keep moving on. Take a look here. Angle DAB is acute. A cute little angle, right? From D to A to B. Here's my acute angle. They want to know which angle is obtuse, larger than 90 degrees. So they want to know which angle here is obtuse, larger than 90 degrees. And it looks to me that it's this guy right here. He's the one who's larger than 90 degrees. But here is the deal, and I will know who's paying attention right now or not, because the biggest problem we seem to have on these problems is not identifying obtuse, it's how to properly label. So you got two ways of doing it. You could either write an abbreviation for an angle symbol and write the three capital letters A, D, C, angle ADC, or you could have went in reversed order and called it angle CDA. But what is imperative is that you have it labeled as an angle. If you just write down the three letters, it is half wrong. Let's keep moving on here. Let's take a look. Which segment is perpendicular to segment DC? So perpendicular, hopefully we know, means that it intersects and forms a right angle. So which one is touching DC and makes a right angle? That would be segment CB. Now again, I'll know who's paying attention because we have a little bigger problem trying to identify perpendicular and parallel. But when it comes to labeling it, if I want to say segment CB, I write the two capital letters, and I could either write the word segment in front of it, but I don't like writing with my smartboard right now, so I'm going to go and put the abbreviation. Segment CB. You could also call it segment BC, right? Let's take a look here. Parallel. If they asked you on the test what parallel is, remember parallel is like an equal sign. They will not touch. So if I had to figure out which segment would be parallel to segment DC, the one that's never going to touch it is right here. That is segment AB or segment BA. Make sure to understand the difference. Perpendicular touches and makes a right angle. Parallel never, ever, ever touches. So if you turn to lesson 83, you could go and use your handy dandy chart to help you out here. A brick has the shape of what? Is this a cylinder, a sphere, a pyramid, or a rectangular solid? And if you looked on lesson 83, you would see that guy's name is rectangular solid. He is not a square. He is not a rectangle. Pretty easy right there if you use your book. Here's an old friend of ours. What number is 2/3 of 21? Well, I cannot figure out 2/3 of 21 without thinking about what 1/3 of 21 is. And in that case, you start off by dividing by the denominator, of course. 1/3 of 21 is going to give me 7. So I could put 7 into each one of these little rectangles, right? Each one of these 1/3s are 7. So 2/3 of 21, I got 1/3 there and I have 1/3 there. That tells me the answer is 14. Now, if you don't like drawing out your rectangles, one other way of doing this because we now know that the word of truly means times, right? So if you were going to have to go and try to figure out 2/3 of 21, you could just set up 2/3 times 21 over 0, or 21 over 1, excuse me. Because that's 21, I'm going to turn 21 into a whole number by giving him a denominator of 1. Now, I actually think this is more work. It's going to end up being a pretty large number here, right? 21 times 2, or 2 times 21, hey, that's 42. 3 times 1, that's 3. And I have an improper fraction there where I would have to divide it out, right? 42 divided by 3, 3 divides into there one whole time, multiplies back 4, 3. It's going to subtract 4, 1. I bring down my next number, my 2, and 12 divides by 3 4 times. Either way will work. I personally still think it's easier setting it up like that, but if you are uncomfortable using the rectangle method, just go ahead and multiply it out and change your answer into a whole number. Here is a friend of ours that we've been practicing since way back on lesson 79. Write a fraction equal to 2/3. We see this every single day, and I have people still stumbling on it because the first thing you should do is write your 2/3. Don't try to do it all in your head. Write a fraction equal to 2/3 that has a denominator of 9. So leave yourself some room in the middle and go ahead and make a new fraction bar with a denominator of 9 on there, right? Then we got to figure out what my magic number in the middle is. And guess what? It's a times problem. Some people are still putting in divide here, but if I'm starting with a denominator of 3 and trying to make it into a 9, you're not reducing. This number needs to get bigger. So I have to use multiply, not divide. So 3 times what is going to equal 9? And in that case, your answer would be 3, right? If I'm multiplying the denominator by 3, I also have to multiply the numerator by 3. Now let's go ahead. 2 times 3, hey, that's 6. When you're all done, if you wanted to check it out, feel free to go and use cross multiplication because these two fractions should be equivalent, right? 9 times 2, yeah, that's 18. 3 times 6, hey, that's 18. A good way to check that you've done it correctly, because if they are not equivalent, you did something wrong. Take a look here. What is the median of these 7 scores? So what do we know about medians? The first thing I have to do is get them arranged from lowest to highest, right? I don't think we have too many people who are struggling with that concept still. Get them all organized from lowest to highest. I have 3 80s. Now I'm going to go over here and put down my 85. And then I'm going to have to go after those 90s. Get them in order from smallest to biggest. 80, 80, 85, 90, 90, and here comes my 100. So median just means my number in the middle, right? I have 7 numbers, so that'll be an easy median to pick out. I have 3 on this side. I have 3 on this side. So my number in the middle is 85. Lots to cover this morning. Right, 0.625 in words. So I don't have anything here in my whole numbers, so I'm not going to have to use the word and. I don't want to say 0 and. So let's just go ahead and name this number. Name the number, then name the group. So the name of the number is 625, right? I don't think there's anybody in the room who couldn't go and say 625 is pronounced 625. Then you just have to be aware of what group number it ends on, and it ends on the thousandths. The trickiest part of this, don't make the mistake and say thousand. There's a big difference between a thousand and a thousandth, right? 625 is the name of the number. Now name the group. Thousandths. Not too tough if you break it down in the 2 steps. Name the number, name the group. Take a look at this one. This is not a divide problem. Remember, when you have the funky little tail on the divide box, that is a square root sign. This problem is asking you for what's the square root of 16. And remember squares. What number times itself? Because that's what a square is, right? All sides are equal. What number times itself is going to equal 16? And in that case, it's got to be 4. Because 4 times 4 equals 16. So the square root of 16 is 4. Here we have a fraction multiplying problem, 3/8 times 1/2. Please, now that we started dividing fractions, do you flip anything on a times problem? No, you do not. It is just numerator times numerator, denominator times denominator, right? 3 times 1, hey, that's 3. 8 times 2, denominator times denominator, that is 16. You don't flip anything on a multiplying problem. Let's go and try this one. Fraction subtraction. 5/6 minus 1/6. All you are adding or subtracting is the numerator. 5 minus 1, hey, that's 4. The denominator stays the same, right? 4/6. But here's where it gets just a little bit trickier. Are you going to leave the answer as 4/6? They are both even numbers. What can I divide into it to reduce? Since I'm reducing, I'm making it smaller. So I do want to divide. 4 and 6, if they're both even numbers, I know I can use 2, right? 4 and 6 are both in the 2 multiplication chart row. They are both multiples of 2. 4 divided by 2, hey, that's 2. 6 divided by 2, that's going to give us 3. And there is nothing I can divide into both 2 and 3 to make it any smaller. Let's keep moving on. Our first divide problem of the day. Now, we should know that when you do a fraction divide problem, change divide to times and flip the second fraction upside down. But check this out. 3/4 divided by 3/4. I could change divide to times. I could flip it around, and I would know that I'm ending up with 12/12, which equals 1 whole, right? 12/12 equals a whole. How did I do that so fast? Well, this, if you were paying attention, any number divided by itself always is 1. I mean, you could change divide to times, flip the second fraction, but 5 divided by 5 is 1. 9 divided by 9 is 1. And 3/4 divided by itself is going to be 1. Check out this one, 4 1/8 plus 1 5/8. Well, let's go ahead and do the fraction side first. 1/8 plus 5/8, hey, that's 6/8. Don't forget to do the whole number side. 4 plus 1, that is 5. But do I want to leave an answer as 6/8? They are both even numbers. I can go and divide both sides by 2. 6 divided by 2, we should know that's going to give us 3, right? 8 divided by 2, hey, that's going to give us 4. But the last step, don't forget to bring your whole number back into the answer once your fraction is reduced. We end up with 5 3/4. And our last problem of the day, what is the perimeter of the square? Well, if I look here, I can see that this side of the square is 3 centimeters. And they are asking for perimeter. That's the distance all the way around. So that side's 3, and I know that this side is 3, and I should know that that side is 3. Then it's just a matter of 3 plus 3 plus 3 plus 3, or I could go 3 times 4. Perimeter is a straight line, so I don't have to square anything, and it would be 12 centimeters. Okay, no Socrative quiz this morning. Use any extra time on whatever I tell you to work on, and good luck.